Welcome back to our sequence on real-world considerations in engineering design. In this session, we will take a brief look at how economics limit what an engineering design can do and be. Estimating product price and tailoring costs so that they do not overrun the price when taking into account overhead and profit is an important part of keeping an engineering design realistic and viable throughout the design process. Like other constraints in this series on real-world considerations in engineering design, economic constraints differ from economic consequences in that they must be considered and integrated into the design solution. Price and cost simply cannot be ignored at any stage in the engineering design process. Although different from a corporate setting, we are nevertheless obligated to address economic constraints in the classroom or other educational setting, not only because economic issues of price and cost do indeed come up in the real world, but because they are also required by the organization ABET, which oversees what we teach to engineers before granting a degree. ABET defines certain outcomes which students are expected to have once they graduate. Outcome C states that students should have an understanding and ability to design within economic constraints. Let's take a look now at what this can look like during the engineering design process. By far the most common economic constraint for an engineering design is cost and then price. Early on in the design process, it's important to identify a target cost and to design, revise, and deliver well within that cost. Cost includes both materials and labor, as well as other costs associated with producing a product or design before it leaves for its final destination, the customer. Price includes both costs as well as overhead, including transport, marketing, and planning, and a profit margin on par with the industry in which the design or product is marketed. The first part of establishing or estimating a price is to try and identify what the market is presently bearing or offering for particular categories of designs or products. Researching the present market can involve looking at available products for a number of categories that would also contain, in the future, the design at hand. Pricing of similar products can usually be done in a straightforward way via location of use, the function of the product, the geographic area where it is used, or other grouping that makes sense. Let's take a look at an example of identifying price by location of use. Suppose a design team is trying to build an air pollution sensor that will be mounted on a bicycle and is targeted towards the urban bicyclist and preserving the health benefits of biking to and from work. In this scenario, it makes sense to survey other products mounted on bicycles and marketed toward those using their bikes in cities. From a brief survey of the products that are already available for urban bicyclists, the cost of these products is seen to range from about $8 to almost $500 retail. $500, however, may be more than many are willing to pay for the entire bicycle, and is likely reserved for the more elite of bikers. A more reasonable ballpark for marketing an air pollution sensor to protect bikers of broader socioeconomic range could be in the $40 to $80 range based on this brief survey of products. At least $40 to $80 is a good place to start. In another example, let's look at a system designed to monitor wrist posture with intentions of preventing carpal tunnel syndrome and other health consequences of incorrect posture while using computing and other devices. As expected, there are many devices already on the market to address posture, ranging from products like Fitbit, which monitor activity and exercise throughout the day, to products that are more specifically targeted at monitoring posture. This survey of devices identifies a ballpark for a consumer posture monitoring device between $40 and $130, with a price point of $80 seeming reasonable for a device sold directly to the consumer rather than going through medical practice and the healthcare system. While in many cases, a product survey by location of use, functionality, or other criteria is straightforward and easily accomplished, in some cases a design may have no apparent competition. In these cases, it becomes more of a challenge to ensure that pursuing the product is not going to turn into a dead end for the design team or for the corporate investment in the design. While there is no accepted or defined method for identifying viability of a design when no competing products are apparent, there are nevertheless some steps the design team can take to ensure that they are not jumping into a dead-end design effort. First and most obvious, the burden is on the design team to know and provide evidence for the need for the product. No need equals no possibility of a successful product, except in the very rare, highly publicized cases where the consumer suddenly becomes awakened to a need by the appearance of a product in his or her hand. In this example, the design is targeted toward monitoring baggage mishandled by commercial airlines. While we all have a story or two to tell about a baggage nightmare experience with an airline, is it just us? Just an isolated occurrence? Or does baggage mishandling really create a problem for enough people that it is a problem worth solving? After rummaging around for evidence, we find that indeed, lost baggage is not only a major source of stress, but the leading source of stress among travelers. That's an ace in the hole to support the actual need for devices that reduce lost baggage stress. Now that we know that lost and mishandled baggage affects more than just us, we can move on to identifying the financial costs of the problem. Yes, stress is annoying, but does it go any further than that? In addition to causing such inconveniences as chronic disease and even death, stress costs money, to the tune of about $300 billion per year in the United States alone. Anything our design can do to reduce stress then has a hope of reducing these real financial consequences of stress to many Americans. So far, we have provided evidence that our design, while having no immediate competition, addresses a need to relieve stress and saves money by reducing stress. But we still have no idea of a price point, not even a ballpark. For this, we can look at other products that accomplish the same thing, reducing stress in other sectors. It's truly amazing how many devices are marketed to stressed out Americans. Portable devices, as a subgroup of these stress relief devices, range in price from about $400 to about $200, providing us with a ballpark of the price point for our own design to reduce stress. Last but not least, although engineers are not market research experts and market research is usually not at the center of their job description, it never hurts to ask potential customers how much they are willing to pay for a certain design. Customer surveys early in the design process can range from short surveys of a small cross-section of potential users to informal conversations with those in one's personal and professional network. Whether a survey such as the simple Likert scale set of questions or informal conversations, questions posed to potential customers should contain both indirect and direct questions. Individuals tend to answer questions about how much they will pay for something they see as a need or want for optimistically. Indirect questions reduce this optimism bias and can be of great help in identifying a preliminary and realistic price point. Once a price point is established, even a preliminary or ballpark estimate, it's possible to estimate costs to set targets and ensure again that the design team hasn't embarked on an impossible design highway. Estimating cost is a matter of understanding not only materials and labor costs, but also adding in reasonable estimates of overhead costs and profit for the industry to which the design is targeted. Materials costs are typically estimated at volumes representative of how many devices are expected to be sold as part of a successful product. Labor costs are also estimated at these mass volume levels rather than onesies or twosies that are typical of prototypes in the early design process. On top of materials and labor head costs are overhead costs, which, as shown here, can be estimated by country and by product sector. Overhead rates range from 8 to over 30% in companies that successfully produce consumer electronic products for major manufacturing centers in the world. From these estimates, it's certainly easy to understand why many American companies outsource manufacturing efforts to countries that have much lower overhead rates, and thereby enable companies to be more price competitive in the highly competitive consumer electronics industry. Once a country or countries are selected for potential manufacturing, projected overhead rates can be further adjusted by narrowing the product down to a particular sector. For example, gaming devices tend to have higher overhead rates regardless of country of manufacture, while computers have some of the lowest overhead rates. Country-based rates can be increased or decreased accordingly based on the target sector for a particular product. And when needed, overhead rates by both sector and by country can be identified for cost pricing purposes. No cost pricing effort is complete without including profit in the equation, and profits vary widely, not only by product sector, but by company. Consumer electronics is a great example of this variability, with two big companies, Samsung and Apple, taking profits over 35%, while smaller players in consumer electronics should project profits no more than 10% to be competitive in these markets. The Apple iPhone profit has been estimated at almost 70%, which sounds wonderful for Apple. For other companies to break into a market dominated by so few names, they must undercut these prices considerably to market successful designs, regardless of whether they are offering superior or comparable products. In brief, estimating price points and cost pricing is very complicated, but failure to make some effort to do so can lead to premature failure for the engineer, the design team, the product, and the company. Economic constraints are complex and extend well beyond this short introduction. But even at the earliest phases of a design effort, engineers can use some of these techniques to realistically identify the feasibility of a proposed design and eventual product. Thank you for joining us. We certainly hope that this introduction to design pricing and cost has been helpful, and that you'll join us again as we look into additional real-world considerations in engineering design.